Welcome to the IoT Solutions World Congress Extend 2022. To this session, develop a successful smart product ecosystem, how an IoT developer transformed from light bulbs to smart building solutions. My name is Paloma, and I'm Senior Product Specialist at Alter SmartWorks IoT. We are delighted that you are joining us to watch this presentation. Although this session was pre-recorded, we invite your questions and comments, so please reach out to us. You'll find our contact information at the end of this presentation. So let me start with a brief introduction about us. Alter was founded 37 years ago in Detroit, Michigan, and it started as a software and services provider to product engineering groups at automotive companies. And since then, the company has grown a lot in all terms, and it has also evolved a lot. And all this growth has been done having in mind that our main goal is to help customers transform in the future with the convergence of simulation, high-performance computing, and artificial intelligence. And we are able to do that because in addition to our traditional offering of tools for design, modeling, visualization, and simulation, we have now tools to include data analytics and AI in the business to develop smart connected products using IoT and to use high-performance cloud computing into your business. All these new tools that we have added to our offering have the aim to help all the companies that are trying to become more digital. In 2019, 24% of organizations with IoT technologies in production or IoT projects in progress were already using digital twins. 2 years later, half of large industrial companies were using digital twins, resulting in those organizations gaining a 10% improvement in effectiveness. And it is expected that next year, digital twin market will reach $15 billion. So linking the physical and digital worlds using IoT technologies could create up to 11 trillion in economic value in 2025. So with all the tools we have in our expertise from many years in different areas, we can provide the companies with what we call the Alter Digital Twin Platform, in the sense of the ability to join all our different tools to help the user creating their specific digital twin. Because by creating a digital representation of a product, companies will be able to support decision making during the development phase, to optimize the performance of the product during operation, and to provide insights for closing the feedback loop in the sense of continuous development, either driven by simulation models or historical data. So to link the virtual with the real world, we have all these different building blocks that we can combine as needed to enhance the different use case for any company. So that way, we can end up creating something like this example. So what we have here is a tire that doesn't have a physical sensor to monitor the brake disc temperature and its energy. But using one of our system simulation softwares, we were able to get this value by developing a simulation model with the data from the disc speed, the brakes pressure, and the amount of time of appliance of this pressure. And thanks to connecting this to our IoT platform, we are able to keep updating this data while we receive new data in real time from the sensors that we do have. Because this IoT platform is the one that hosted both the digital twin of the tire and the FMU, which contains the simulation model. So from all these analysis, we extract several conclusions. First of all, there is a trend that has become more powerful, the global evolution towards smart connected everything. It is a reality. Smart products are now mainstream, and there are more than 21 billion sensors connected worldwide. So that's why 79% of organizations are planning to invest into at least one IoT project in the coming 2 years. But having said that, we know that IoT projects have a failure rate of 75%. And this lack of success has nothing to do with the IoT itself, but with the fact that implementing IoT isn't something straightforward. And what makes the difference between success and failure is how companies address this digital transformation. So why are companies moving to smart connected everything? Well, some of them may want to improve operations by enhancing the product's functionalities. Others may want to improve the user's experience and give them control over the product to provide a better customer experience. And others simply want to offer their product as a service and therefore generate recurring revenue streams. So that's why during last years, product development has evolved. And this is the reason why our portfolio has also evolved. From tools that cover product design and product engineering to the development of a smart product, which round out our current offer with tools for embedded development, software development, and user empowerment. And thanks to the continuous improvement of all these tools, we are able to help our clients to success on the new challenges they have to face every day. Because it is true that building a smart connected product takes longer, is more complex, and has more risks and costs than normal products. And this is why IoT products are often abandoned. But it is also the reason to use an IoT platform, as it provides the tools needed to accelerate the process of developing a smart connected product. Because after product design and engineering, you will need to connect your products to one another into the internet. So if you want, for example, to connect your fleet to an application for fleet management you have developed for your end users, you will need a software backend to provide automation, coordination of data, and that is something that can be done using an IoT platform. Also, if you want to connect any other kind of assets, such as the robots on your manufacturing plant or the wind turbines at your wind farms, so that you can perform predictive maintenance. And same if we are talking about connecting buildings with a mobile app for controlling building equipment, or even if your use case is more complex and you need to rely on the edge to reduce latency and minimize data transfer costs, for example. And that is how a company ends up having not just a smart connected product, but a smart product ecosystem. Because during the process, they will realize there are more assets, machines, and tasks they will want to add to this ecosystem, so that they end up having all the processes connected to get the best out of all them. So to talk more about the smart product ecosystems, let me introduce Dane Hollenkamp, Chief Operating Officer from Toggle. Toggle is a company that produces lighting solutions for companies, and Dan today will tell us more about how they are transforming their business thanks to SmartWorks IoT.
Hello, my name is Dan Hollenkamp. I'm the Chief Operating Officer of Toggled. Today I describe Toggled as a company focused on unlocking data found in buildings and using actionable analysis to improve both user and environmental outcomes. This is a long throw from the light bulb manufacturer we were just a few years ago. Today I'm going to talk about the path we took to create a connected lighting and building management solution. Starting in 2007, Toggled helped kickstart an LED lighting revolution by pioneering the direct replacement of fluorescent tubes with LED linear lamps. Over the years, we've evolved our product lines, improving efficacy, quality of light, and adding controls and features, including the first mass-market dimmable tubes. In the beginning of our lighting journey, we were busy keeping up with improvements as LED packages were becoming cheaper and more efficient. But after a while, the rate of improvement began to slow, and it was clear that lighting controls were going to be the next target for continued energy savings. Wanting to continue innovating, we were faced with the challenge of how to provide a simple and cost-effective lighting control system in commercial and industrial spaces. We already had phase dimmable lamps in the residential market, but traditional household dimmers don't work in commercial spaces due to the higher voltages and load requirements. The equipment that did work was expensive and time-consuming to install due to the need for additional control wiring. These factors were stalling adoption in the industry. It was clear we wanted to create a system that would avoid control wires. But as you can imagine, there's a lot to consider when moving from a standard product to a connected one. One of the first challenges was to figure out how the devices would communicate. Through much research and experimentation, we landed on creating a wireless mesh network to control our lamps. We began adding Bluetooth radios and microcontrollers to our existing designs, putting us on the path to creating smart lights. Part of the appeal of using Bluetooth was that everyone was already carrying around a lighting controller and setup tool in their pocket. All they had to do was download our app. So we needed to create an app. Our first app allowed single user accounts to add lights and switches to groups. We would authenticate users and sync some configuration data with one of the big cloud providers, but that was about it. No device data was going to the cloud or anywhere in the building for that matter. While we were developing a sensor to automate control of the lights, we were beginning to realize that there's an enormous amount of data about the operation and use of buildings trapped in these lighting networks. We wanted to capitalize on the data, but we were not sure how to do it with our system at the time. And at this point, we only had 2 electrical engineers, 2 firmware developers, and half a software developer working on this project. It was clear we were going to need some help. Attempting to speed up the development process, we acquired a company that was already pushing building data to another large cloud provider. We made their existing databases work with our devices and wrote a driver for our lights on their existing edge gateway. It worked, and we were pushing data to the cloud, but every time we added something, we also needed to add a field to the database or hack in support for a new feature. Every change required coordinating tickets between the front-end developers, back-end developers, and edge developers. Very quickly, it became difficult to scale the solution, and we began spending more time maintaining the infrastructure than creating new features. At this point, we were still struggling to do anything meaningful with the data, as it always seemed to be in the wrong format. Up to this point, we had learned a lot of what not to do, and realized that most cloud platforms are a little too broad and multi-purpose for our use. We learned designing performant database structures is hard. There will always be something new, a new device, feature, data type, or connections. Either you end up changing your database or having generic fields that are hard to manipulate. Communication from the edge to cloud requires a considerable amount of continuous development to keep it compliant, secure, and working. It's not obvious where to execute code that manipulates data or triggers events based on the data once it's in the cloud. Scaling and maintaining secure cloud infrastructure is difficult. Everything takes way longer than expected. We knew there had to be something more suited to our needs, and there was. For Toggled, Altair SmartWorks was a game changer. It let us stop focusing so much on our infrastructure and let us start focusing on what we do best, our devices and data. SmartWorks provided the framework, connectivity, and resources to develop at a much quicker pace than we could have otherwise. It took less time and resources to rebuild our solution on SmartWorks than we were spending on maintaining our old platform. SmartWorks is purpose-built to handle device data. We only needed to model the devices with its properties and actions. Also, we only needed to focus on the devices at hand. There's no need to add extra fields for other devices or features that we'll need in the future. We didn't have to find the right database to use or what server resources we would need to scale. A model was the single source of truth for our devices, and it coordinated changes across the front end, back end, and the edge. Getting data from devices to the cloud is not trivial. Again, SmartWorks allows us to almost ignore the infrastructure required to do this. We simply needed to write a driver for our devices, and the edge compute platform handled publishing our data securely to our cloud using the models we had previously created. Once the data is in the cloud, what do you do with it? Well, SmartWorks has connectors, analytics, and a place to execute functions right out of the box. It's made it easier to actually do meaningful things with the data. We can simply connect without having to reformat, write connectors for our data. In addition, we can easily ingest data from other sources and APIs. SmartWorks has saved us both money and time. We don't need as many developers, and all of our developers are creating new features and values that our customers see, not creating and maintaining infrastructure that is hidden. It also allows us to react to customer requests much quicker. Instead of saying our platform doesn't support that use case and losing a project, we can consider delivering a solution faster than the hardware is shipped and installing, or even upgrade the system after the install. So far, we've talked about how SmartWorks has made it easier for us to develop a connected product ecosystem. But why would you even go through all this trouble? Well, previously when we sold a lighting device, after the physical sale, we did not interact with our customers. A small percentage might reach out for installation clarification or warranty issues, but most would only interact with our resellers. Moving to a connected product has allowed us to stay close with the end users, even when we're not directly selling the device to them. Having a mobile app and web portal that customers use on a regular basis gives us insight into how our customers use our products and provides a communication channel back to that customer. Knowing how our current products are used allows us to design better products in the future. Imagine knowing the average duty cycle and normally operating temperature of products in the field, except we're not looking at a sample size, but the entire population of production devices. Have you ever built the devices? If we loosen the specifications on the next revision, how many failures would we see? What percentage of our customers would even notice? We can tie field failures to the actual operating data of the device. Do we see any correlation between failure and how the products are being used? Can we identify other devices in the field that have the same characteristics and either selectively recall them or push firmware to protect them from failure? Perhaps all these products are being used outside of their intended operating range, and the users have avoided their warranties. In the coming future, connected device data-driven product design will give significant advantages over traditional designs, as they'll become more tailored to the user's actual needs and can be optimized both in performance and cost for these tasks. With our old business model, a new source of revenue was derived from a physical product that was designed, manufactured, and physically installed in a building. Now we can create new products based on data and the way that devices interact. These solutions provide continuing value to our customers and can generate additional revenue without adding to the existing physical infrastructure. When we develop better models, better algorithms, or new connections, we can apply them to existing installations instantly. These non-hardware products create recurring SaaS revenue that both benefit Toggled and our customers. It's good for Toggled because it continues to generate profits after our initial sale and allows us to keep innovating. Good for our customers as they only continue to pay for a product that brings them benefit, and they can feel secure that we will continue to maintain and support their solution. And of course, what we actually set out to produce, a connected building platform that allows us to break down data and control silos in buildings and helps all the subsystems operate in unison. More than ever, buildings are seeing changing use patterns and required to use less resources. It's important to have buildings that can quickly adapt to these changes, whether it's HVAC set points being driven by motion sensors from the lighting system, using plug-low controllers to turn off the monitors and desk lamps that were left on overnight, or simply providing better lighting when and where people need it, while using less energy as possible. Toggled IQ provides these solutions. Today, thanks to SmartWorks, we have an IoT platform that manages all of our device data, secure edge connectivity, and provides the back end for our mobile and web app with little worry of adding new devices or scaling the solution as we grow. This solution has allowed us to compete with large organizations while having a much smaller team. And it has allowed us to focus on our domain expertise and not dedicate resources to building and maintaining infrastructure that does not create value to our customers. Thank you.
So today we've learned how to leverage smart product ecosystems and how to success on building a smart connected solution as the soil company did. Big thanks for watching, and if you have any question or you simply want to know more about how to create a scalable secure product ecosystem faster and with smaller teams, please feel free to reach out to us. Have a great day.